Hello, good morning, everyone. So this is another topic regarding the subject CRDR, and the topic is entitled Display. So we'll be discussing here the different displays or different monitors used in computed and digital radiography. So we'll be discussing here the plasma display panel, also the cathode ray tube, and the LCD, and of course, one of the films used in order to in order to view the radiographic digital image in a hard copy, which is the laser film. So to start, we go with the computer monitor. So mo to siya, si plasma, si LCD, and CRT will be discussed in this topic. Okay, so first we go with plasma. A plasma display panel, or PDP, is a type of flat panel display often used for large television displays, typically above 37 inches or 940 millimeters. Many tiny cells located between two panels of glass hold an inert mixture of noble gases such as neon and xenon. The gas in the cells is electrically turned into a plasma, which then excites phosphors to emit light. So later on, I'll be discussing how things happen within a plasma display panel. Okay, so isa-isa ho na to na siya. Ayan. So here are the breakdown kumbaga sa inyong plasma display panel. So the xenon and neon gas mixture in a plasma television is contained in hundreds of thousands of tiny cells positioned between two plates of glass. So this will be your front plate glass. Dito nyo makita itong mga pictures. And then this is the rear plate glass. Okay? In between those is kaning mga tiny cells that contain inert gases such as xenon and neon. Long electrodes are also sandwiched between the glass plates in front of and behind them. So the electrodes is this one. Okay? The display electrodes and the address electrodes. The address electrodes sit behind the cells along the rear glass plate. Okay? So mo siyang address electrode, which is in contact with the rear glass plate. Both sets of electrodes extend across the entire screen. Okay? So this electrode extends, sakop niya tanan bang screen. Okay? The display electrodes are arranged in vertical column. So as you can see, vertically arranged siya along the screen, and the address electrodes are arranged in horizontal rows, kaning yellow strips here. As you can see in the diagram, the vertical and horizontal electrodes form a basic grid. Okay, so kung tanggalon mo ni sila, kaning in between the electrodes, and you put them in contact with each other, you can see that it is basically a grid. Okay, so kung ma-remember niyo to active matrix array discussed last midterm, bring nga yung structure, si data lines, it runs vertical, and then si gate lines, it runs horizontal. Okay, ano siya. And then, to ionize the gas in a particular cell, the plasma display computer charges electrodes that intersect at the cell. It does this thousands of times in a small fraction of a second, charging each cell in turn. So for example, this is your display electrode, and kung asa sila mag-meet, maghatag na sila og surface discharge or surface charge sa isa ka cell. Okay, so remember that each cell contains a gas, either neon or xenon. When the intersecting electrodes are charged with a voltage difference between them, so an electric current flows through the gas in the cell. Okay, so pag maghatag na ni sila og voltage towards the cell, it will provide an electrical current, no, or electric current flow towards the cell. As we saw in the last section, the current creates a rapid flow of charged particles, which stimulates the gas atoms to release ultraviolet photons. So once this display electrode and the address electrode provide a surface charge, creating an electric current which will ionize the gas within the cell. When the gas is being ionized within the cell, ultraviolet photons are created. Okay? The released ultraviolet photons interact with the phosphor material coated on the inside wall of the cell. The phosphors are substances that give off light when they are exposed to other light or being stimulated, such as X-rays. Okay, so again, display electrode and address electrode will give a surface charge sa inyong each cell, and then it will provide an electrical current ionizing the gas within the cell, and then this gas will this gas when gas is ionized, ultraviolet light is produced. And ultraviolet light is produced, it will interact with the phosphor in the wall of the cell. Okay, and then when an ultraviolet photon hits a phosphor atom in the cell, one of the phosphorus electrons jumps to a higher energy level and the atom heats up. So pagka-produce ni ultraviolet light here, okay, it will interact with the phosphor on the wall of the cell, and then the electrons on the phosphor area will get excited and heat up. When the electron falls back to its normal level, it releases energy in the form of a visible light photon. Okay, so to summarize, again, si display and address electrode will create a surface discharge. Okay, once the surface discharge reach a certain level, it will produce an electric current flow towards the cell. Once the cell acquires this electric current flow, it will it will ionize the gas within the cell. Once the gas is ionized within the cell, it will produce UV light which interacts with the phosphor located in the wall of the cell. Okay? Once the UV light interacts with the phosphor, the electrons of the phosphor will get excited. Once it gets excited, pag fallback na sila sa ilang normal level, it will produce uh, an energy in the form of visible light. Okay? The phosphors in a plasma display give off colored light when they are excited. So, ano to? Every pixel is made up of 3 separate subpixels. So, kani siya, 1 pixel, 3 cells. Okay? Each with different colored phosphors. One subpixel has a red light, one subpixel has a green, and the last pixel is a blue light phosphor. These colors blend together to create an overall color for the pixel. So nakadepende gyapon na siya for each pixel kung unsang intensity sa color and what color will the pixel emit on the monitor or in the glass. Okay, and the display. By varying the pulses of current flowing through the different cells, the control system can increase or decrease the intensity of each subpixel color to create hundreds of different combinations of red, green, and blue. In this way, the control system can produce colors across the entire spectrum of colors. Okay? So, ganyan ni siya. Di ba, we have, in a pixel, we have 3 subpixels. We have red, green, and blue phosphors. Okay? So, ang trabaho ni pixel is it will mix these colors in order for it to provide a certain color. And with varying pulses of electric current provided by the electrodes, okay, it will provide, the pixel will also provide an intensity of colors. So for example, ang task ani na pixel is to produce a color of blue, violet, ana. So magmix si pixel og color na violet, and then with the different energies or different pulses of flow or of current, ma-change niya ang intensity sa violet into light or darker na siya na color. Okay? Yan ang iyang trabaho sa plasma. Okay? So, muna to siya for plasma. Let's go with another one, which is the liquid crystal diodes or liquid crystal display. They are lightweight, portable, less expensive, and available in a wider range of sizes compared sa inyong plasma. Their flat shape allows them to take up less space. So, kana makita ninyo na TV karon, di ba, makita ninyo LCD display, may ana. Okay? Mana siya. And, they generate less heat, so dili sila mo init jud kaayo, di pareha sa mga uban na mga monitors na mag-init ang likod. And they have a longer life with less maintenance than the CRT if they are cared for properly. So, CRT is cathode ray tube. So, later on, i-discuss mo na ko po na unsa ng CRT. Okay? So, mas taas sila ang life and dili sila kinahanglan bantayonon og maintenance. Okay? They do not produce veiling glare and have much lower reflection of ambient light of their surface. So, unlike kung nakaabot pa mo anang TV na dakong likod, that is what we call the cathode ray tube na TV. Okay? So ang disadvantage mong gud ana is it produces veiling glare, and kanang pag bright kaayo ang inyong suga sa balay, it will reflect the light, dili ninyo maklaro na kaayo, which causes na di ninyo maklaro kaayo ang inyong ginatan-aw sa TV. Okay? What do I mean by veiling glare? Ngani. Okay? So, the first image is without veiling glare. Pag naay kaning second image, it's an image with a veiling glare. So, medyo bright siya, kumbaga dili na nimo maklaro kung saan naa sa vicinity sa veiling glare. Okay? Siya. So, the parts. It consists of two thin sheets of glass, each containing a light polarizing layer which is perpendicular to the other sheet. So, same sa yung plasma panel, it has two sheets of glass, the front and the back side na glass. Okay? The LCD process involves tricking these layers into allowing light to pass through when we wish by using a special material in between them. So later on, I will explain say pasabot aning tricking these layers into allowing light. Okay? But for now, let's focus on this statement. Inserted between the polarizing glass sheets of an LCD is a layer of pneumatic liquid crystal material. Muna siyang liquid crystal display or liquid crystal diode siya, because the main part of this monitor is its pneumatic liquid crystal material, which is hydrogenated amorphous silicon. Liquid crystal compounds have a crystalline arrangement of molecules, yet they flow like a liquid. So kung sa tong ginagamit nato sa detectors, no? Ginagamit nato sa detectors for image receptor na amorphous silicon, maputi siyang ginagamit nato dali sa liquid crystal display. However, its behavior or its nature is hydrogenated. So, mo to siya, crystalline ang iyang structure, but it behaves like more like a water, more like liquid, fluid, ana. Okay? The term pneumatic means that the molecules have a thread-like shape and tend to keep their long axes aligned. Okay? So when we say pneumatic, ang ilahang structure, doon na to, since crystalline man sila, okay, ana, and parallel sa each other ang ilahang long axis. Tightly compact, long axis, ano. Hindi sila pareha atong uban na crystals na mag-wara-wara ang ilahang what do you call this? Ang ilahang orientation. Yes. Transparent conductors made of indium tin oxide act like flat-shaped wires. So, ang conductors diri is what we call the electrodes. Okay, this one and this one. Okay, transparent conductors act like flat-shaped wires to transmit electricity throughout the system. Rows of these transparent conductors are built into one glass plate, and columns of vertical conductors are put into the other plate. Okay, so it's either ang orientation sa isa ka flat-shaped wire or sa isa ka electrode is horizontal or vertical. Okay, which is attached to one glass plate each. Each intersection of these two conductors constitute a pixel. The surfaces of the electrodes that are in contact with the liquid crystal have been treated with a thin polymer layer. Okay, again, the surfaces of the electrodes that are in contact with the liquid crystal have been treated with a thin polymer layer. So for each electrode, ang surface niya, which is kani, and sa likod ani na electrode is treated with a thin polymer layer, which is attached to the liquid crystal. This layer has been rubbed in a single direction with an abrasive cloth material to create a finely scratched surface, which provides them a surface na horizontal and vertical na surface. Okay? Tungod na siya sa abrasive cloth material. So, ma-identify nato na kani siya na wires, it runs, or kani siya na electrode, it runs horizontally, and this electrode runs vertically. Okay? Okay, ano man gud ni siya? Okay, this is how the concept of liquid crystal diodes work. So, to understand how LCDs work, it is first necessary to review the concept of polarized light. Since liquid crystal display has a polarizing layer, di ba? Saan na to siya? Yan, light polarizing layer. Here is how it works, okay? As you can remember, if you have polarizing sunglasses, they work to reduce reflective light glare because the plastic used in the lenses contain long, slender, aligned chains of iodine molecules which act somewhat like a radiographic grid. So, di ba pag natay polarized na sunglasses, dili kayo ta maglisod og tan-aw sa dalan na bright kaayo ang sun. Okay? So when we drive, for example, tapos we wear the polarized sunglasses, and medyo init siya, medyo hayag ang sun, dili ta maglisod og tan-aw. Okay? Dili ta magpiyong-piyong na so ito, sulaw. Okay? Di siya sulaw. Okay? With the use of polarized sunglasses. Okay? With these polarizing sunglasses, manggod, it blocks the light, blocks certain wavelengths of light so that dili kayo siya glary. Di wala yung glare na mahitabo sa inyong eyes. Okay? Only those light waves which vibrate parallel to these long chains of molecules can penetrate through. Light waves vibrating in all other directions are blocked by the molecular grid. So for example, yung ani ang inyong in an atomic na or in a microscopic na sense. Okay? So only those light waves that are vibrating parallel to the polarizing layer can pass through. Like this one. Pag perpendicular ang iyahang vibration towards the molecular grid or towards the polarizing layer, dili siya kaagi because it blocks it. Okay? So if it's parallel, it can pass through. Okay? So as you can see, patindog man siya, tapos patindog po ang inyong light wave, so it can pass through. But if the light wave is perpendicular to the molecular grid or the polarizing layer, it cannot pass through. Okay? By placing two polarizing lenses perpendicular to each other, all light will be blocked because those waves that make it through the first polarizing lenses will be perpendicular to the second lens. So, pag is-mix ni mo ni sila, okay? So, makapas lagi ni parallel sa imuhang mga, what do you call this? Makapas lagi ang mga light waves parallel to your polarizing lenses. However, when it goes to the second layers of polarizing lenses, di na siya makaagi because it's not parallel to this layer of polarizing lenses. Okay? So, yung ana ang concept sa liquid crystal display, which will be explained in this slide. Normally, the threads of liquid crystal tend to line up with the direction of the scratches on the surface of the uncharged electrode. So remember that your electrodes have vertical and horizontal because of the abrasive cloth, diba, as mentioned in the previous slides. But the two sets of electrodes, front and back, are oriented with their scratched surfaces perpendicular to each other. So as you can see here, si conductor is kani siya horizontal, this conductor is vertical. Okay? The result is that the liquid crystals line up in a helical or spiral pattern that twists 90 degrees between the two glass plates. Now, light passing into the liquid crystal layer will follow the orientation of the crystals so that the light also twists 90 degrees and is able to pass through the second polarized sheet of glass. So, di ba sa example nako previously, explanation nako is pag magtapal ta og duha ka layer sa polarized lens such as this one, dili makaagi because nga although parallel siya dire, but it can pass through to the second layer of polarizing sheets, okay, or polarizing lens because nga dili na siya parallel with the this layer. Okay? Now, so what are you going to do para makapass si light, no, to the second layer of lens, or in our case of LCD, the second layer of polarizing sheets. Okay? So what ang buhaton sa light is magsulod siya diri na area and then it twists itself in order for it na makasulod siya sa next na polarizer. Okay? So when light passes through this polarized layer, it twists itself in order for it to pass to the second type of polarizer. Okay? So the pixel is considered to be in on state okay, in on state, and light is transmitted through as long as no electrical current is applied to the pixel electrodes. So kung walay electrical current, light can pass through. When an electrical charge is applied to the pixel, it is considered to be shut off, such as this one, or off state. When off state siya, dili makatwist ang inyuhang light, dili siya makapass through. Okay, pag on state siya, light can pass through and can twist itself along with the nematic liquid crystal. So kung sa tong ginabuhat sa inyong light, ingato pod ang ginabuhat sa inyong liquid crystal. Okay, so kung on state siya, light passes through the polarizer, it twists itself, same sa inyong nematic liquid crystal, and then it goes through the second polarizer. If it's off state, it can pass through the first sheet or first layer of polarizer, but it cannot pass through the second layer of polarizer because off state nga siya, off state ang pixel. Okay? The twisting effect, yes, the twisting effect on the light is lost and light is unable to pass through the two perpendicular polarizing filters. This creates a dark spot on the LCD image. This is the basis for the forming of the light and dark areas required to produce an image. Okay? So, yung ani siya. So, dili man yun, tanan image is, tanan display is in need of light. Okay? Dili siya always in need of light. So, there are parts of the LCD display that na dark areas because dili siya always light yun tanan ang needed na colors or needed na display. So, when it's on state, light can pass through and of course, light areas are produced. Pag naka-off state si pixel, ang iyang maproduce na colors is dark areas. Okay, so it's a mixture. The pixels all across the screen can provide a mixture of light and dark areas to produce an image. Okay? By controlling the voltage applied across the liquid crystal layer in each pixel, light can be allowed to pass through in varying amounts, thus constituting the different levels of grace. Increasing voltages untwist the column of liquid crystals more until they are nearly parallel and letting less and less light through. On very large monitor screens, the display must be multiplexed, grouping the electrodes in different segments of the screen together. The separate voltage source for each group to ensure sufficient voltage to all pixels. So there is a na sentence. Increasing voltages untwist the columns of liquid crystals more until they are nearly parallel and letting less and less light through. So, ang relationship man god ni voltage and the light is inverse. Okay? Once you apply voltage, okay, once you increase the voltage, it will lesser intensity of light is passing through. Okay, so increasing voltages untwist the column of liquid crystals more until they are nearly parallel and letting less and less light through. Okay, so when you increase the voltage, okay, ma-off state siya, almost ma-off state na siya. Okay, but when you decrease the voltage, it allows the light to be twisted towards the polarizer. Okay, again, increasing voltage decreases the light that can pass through. Okay, once you increase the voltage produced in the conductor, okay, lesser and lesser light will pass through the polarizer. But when you decrease the voltage from the conductors or the electrodes, more and more light can pass through. So on very large monitor screens, the display must be multiplexed, grouping the electrodes in different segments of the screen together with a separate voltage source for each group to ensure sufficient voltage to all pixels. So pag dako na kaayo ang inyong display, okay, each pixel must have their own multiplex na ang pixels. They must have their own voltage source which could provide sufficient voltage needed by the pixels. Okay. The one remaining need is to supply a source of light. So of course, dili man walay makaagi na light sa yung polarizing layer kung walay source of light. For a passive matrix LCD, a reflective surface is placed behind the entire surface of the transparent sheet, which is this one. Okay, This mirror simply reflects room lighting or sunlight, which then passes through the filters or polarizing layers and liquid crystal layer on its way back to the viewer. Okay, so most for passive matrix na LCD, okay, it acquires light from the room and also from the sunlight, and it emits the light towards the viewer. A source of backlighting can also be provided as is done with a button on many watches. Okay? So it's either a mirror or it backlighting siya. Nagi siya ihang source of light yun. Dili siya mag-reflect lang. Okay? It produces light on its own. Kumbaga, ana. Okay? The display needed for computer monitors and for imaging applications, including radiography, must be much brighter with much sharper resolution and must have high speed response times. When we say response times, it is the time necessary for a pixel to change its brightness. So, kumbaga, pag mag-control ka sa imong TV, tapos pag mag-increase ka og brightness, when we say na paspas ang ihang response time, when you press the increase brightness button, it will readily increase. Paspas ang ihang response ba. Okay? When you press the increase brightness button, ang ibuhang LCD po na display, it will um, increase also its brightness. Okay? Responsive siya, paspas ang iyang response time. For this purpose, the active matrix liquid crystal display or AMLCD was developed. In an active matrix system, each pixel has its own dedicated thin film transistor, same sa inyong image receptor. Okay? So it has its own thin film transistor, and when it has its own thin film transistor, it also has its own capacitor. This allows each column line to access a pixel simultaneously to form a row, speeding up response and refresh times. So with the use of thin film transistors, each column line or to access a pixel simultaneously to form a row, it will speed up the response and refresh times. When we say refresh time, it is the time it takes to reconstruct the next frame. Pag hinay manggod ang refresh rate nimo, mura siya katong sa movie ba na mag-flicker. Old movies, for example, saan ko for example? Wait lang. Ayan. So pag hinay yung refresh times, the images ng frame rate niya is baba. Okay? So mo na siya yung anayhang image. Okay? Iyang makita nimo sa monitor. So medyo ga-flicker siya and pangit siya tan-awon. Okay? Yeah. Okay. So no matter how low the refresh rate, LCD monitors exhibit no flicker because the pixels do not flash on and off between frames as those of a CRT do. Okay? So sa LCD monitors, wala siya flicker, wala siya yung ato ng mga images because kato siya dili man siya wala nagdili naga on and off ang inyong frames in between in between the frames. Okay, wala siya naga on and off ang imong pixels. Just like what CRT do or the cathode ray tube TV does. Okay? The capacitor of each TFT also prevents charge from leaking out of the liquid crystal cell, maintaining brightness and continuity. A bright source of backlighting is always supplied to the LCD layer in these systems. Okay? So, because of the capacitor, dili lang siya store of electricity, but it also prevents the leaking out of liquid crystal cells. Okay? So that dili siya dire-diretso ang seamless ang iyang display. Okay? Dynamic images are produced. The resolution of an active display matrix is often stated in the terms of total number of pixels on the entire screen or in each screen dimension, width and length. For example, 480 by 640. LCD monitors may have resolutions as high as 3 to 5 megapixels. So that means there are 1 million or 3 million pixels, if I'm not mistaken, megaman. Okay, 3 million or 3, yes, I believe 3 million pixels. Okay, 3 million pixels to 5 million pixels. Okay, in LCD monitors. Dot pitch or pixel pitch is the distance between the centers of two adjacent pixels, and the smaller the dot pitch, the smaller is the distance between two pixels, the less graininess is present, and the sharper the image resolution. So kaning graininess is what we call in the radiography as quantum model. Okay? So muna itong ginapangita sa LCD. Lesser ang iyahang dot pitch or pixel pitch so that the graininess or the quantum model is also decreased, thereby increasing the resolution of image. Make sure that when you do not damage man good ang screen when you put or exert so much pressure. And when so much pressure is exerted on the screen, dead pixels can result. So as you can remember sa artifacts na ma-produce sa digital image, when dead pixels are produced sa image, okay, di ba makita niyo na di na siya mag-produce of color. Okay? So now we go with the last one, which is the cathode ray tube. In the video monitor CRT, the anode assembly consists of a screen of fluorescent phosphor crystals, which glow when the stream of electrons strike them. Lateral dispersion of light is minimized by using linear-shaped crystals and aligning them perpendicular to the glass support. So, ingani mo guna siya. Let's draw. Okay, so in a CRT, oh, perfect square. Okay, so ang iyang crystal should be linear. Pareha gud atong sa sa inyong phosphor plate sa CR na dapat linear siya so that ang light dispersion is towards lang gid sa viewer. Okay? Towards sa viewer. Walay dispersion of light laterally towards sa inyong what do you call this? Towards sa inyong other pixels. Ay towards your other phosphor crystals. Okay? Because this could affect image quality. Yes, behind the phosphor layer is a very thin sheet of aluminum which electrons penetrate right through while forming a reflective backing for the light from the phosphor layer. So, sige lang, discuss mo na ako niya. Makita ninyo ang mga parts sa inyong cathode ray tube. As a stream of electrons is emitted from the electron gun, it must undergo three modifications to control its shape, direction, and quality. First, a control grid attached to the electron gun modulates the intensity of the stream up and down over a million times each second. So, bali si control grid, dula-dulaon niya. Okay? Pag dula-dulaon niya ang inyong electrons, stream of electrons. Okay? So, it will go, stream up and down over a million times each second. This ultimately determines the brightness with which the phosphors will glow when struck by electrons. So, say now ang control grid. Ayan. Okay? So, this is the electron gun. Okay? And this is your control grid. Okay? It will vary the intensity of the electron stream. Okay? Second, a focusing coil uses negative repulsion to keep the electrons in a very narrow beam. Then the stream passes through deflection coils which use alternating degrees of charge to steer the stream, directing it in a pattern of lines indexing across the phosphor surface. Okay. So for the focusing coil, kani siya, negatively charged ni siya, same sa inyong electrons. Diba, so you can remember, negative charge, same charge, repel, opposite charges, attract. Okay? So with using that concept, that concept, since negative si electrons and negative food ang focusing coil, so dili sila mag-attract to each other, therefore producing a narrow beam. Okay? Mura siya focusing cup sa inyong X-ray beam, X-ray tube, kumbaga. Okay? Now, the stream passes through deflection coils which use alternating degrees of charge to steer the stream, directing it in a pattern of lines indexing across the phosphor surface. So, ang function ni deflection coil, okay, it will drive the electron stream into the phosphor layer. So, muna ito ginayon ako ganina na aluminum reflector behind the phosphor layer. Okay, so the deflection coils are usually outside of the cathode ray tube itself, situated to surround a narrow neck of the glass tube at the back. In conventional color TVs, the phosphor crystals are of three types, which emit red, blue, or green light, and are arranged in triads across the screen. The three separate electron guns are assigned to scan only the phosphor crystals of one particular color. So, kani siya na cathode ray tube is single electron gun lang man siya. That means it is for black and white radiographic images or for monochromatic data entry screens. So, of course, kung daghan og colors ang inyong TV, that means that it has three electron guns assigned for each color, which is red, blue, or green. Okay? So, unsay mahitabo sa electrons ninyo, one is once it reaches the phosphor layer. Tingnan niya siya. The electron beam scans across the phosphor screen in a raster pattern. When we say raster pattern, it moves from left to right on the uppermost line. This single line is called an active trace as the phosphor crystals are activated to varying degrees of brightness. So, yan ni siya. Okay? So, this is the TV screen na mismo. Okay? You are the viewer. Okay? So, it traces from left to right. Okay? So, ang active retrace ani is this one. Okay? Ayaw mo kalibog. It's a diagonal line. Okay? So, it moves from left to right. Okay? This is what we call the active retrace. This one. And then the beam is then shut off as it indexes back to the beginning out of the third line in the image. This movement is called a horizontal retrace. It makes an active trace on the third line and continues in series, activating all of the odd lines in the image to the bottom of the screen. So, once the electron beam reaches the phosphor surface, it goes from the first line, creating an active retrace, and then goes to the third line, active retrace na sad. Okay, this is what we call a horizontal retrace. Pag human niya dire, it shuts off and goes to the to the third line, and then creates another active retrace. And then it goes to the fifth line and goes to the active retrace, seventh line, active retrace until it reaches the bottom of the screen. Then after niya ma-reach ang bottom of the screen, it executes a vertical retrace. Balik na po siya sa start. Balik siya sa first na balik siya sa taas. Balik siya sa taas. Okay? And begins from line number 2. Since giskip man natong line number 2 ganina, so sa line number 2 siya mag-start. So if this is line number 1, this will be line number 2, and then after ni mahuman ang horizontal retrace, it goes for a vertical retrace and then goes for line number 2, and then it goes to the line number 4, another horizontal retrace, go to the line number 6, horizontal retrace, line number 8, horizontal retrace, line number 10. Ana siya. Scanning all of the even lines in the raster pattern. Each scan down the screen is called a television field. Okay, so field 1 and field 2, this is what we call each field is what we call a television field. Okay, so one active retrace, kumbaga ba, is one field. One active retrace, one field. And every pair of interlaced fields produces one image frame. So field 1 and field 2 will produce one image frame. Okay, field 3 and field 4 will produce an image frame. Okay, and pag na-combine ni silang mga frames tanan, it will produce an image in the phosphor screen. Okay, when 60 Hz electrical current is used, 60 fields will be scanned per second. So that means, if kunwari 60 Hz ni siya, 60 pud ka mga linya-linya dira. Okay? So 1, 2, 3 until it reaches the 60 Hz or 60 lines. Okay? Translated to a frame rate of 30 frames per second, since one frame is produced by two interlaced fields. Of course, pares-pares gid na siya. So that means your 60 Hz will produce 60 fields and will produce a frame rate of 30 frames per second. Since 60 man siya, and by pair ba yang ato ang fields in order to produce one frame. So, you have to divide 60 by 2 to create 30 frames per second. Sorry po. The human eye requires a frame rate of at least 18 to 20 frames per second to avoid the appearance of flicker, such as this one, which can be seen in old movies, which seems to rapidly flash in their brightness, which is present in the CRT, some of the CRT. Okay, so dapat at least 18 to 20 frames per second, which is the capacity of the eye, para dili siya mag-flicker na ingani. Okay, the fluorescent light of the activated screen quickly fades, but since it is refreshed, the refresh time is every 33 milliseconds, it appears as a seamless dynamic image to the human eye. Okay? So mao na siya, since the frame rate is above 60 Hz. 30 frame rates per second man siya, 30 frames per second man siya, so it goes above the capacity of the human eye, which is 18 to 20 frames. So therefore, with coupled with the fast refresh rate na 33 milliseconds, ang appearance ana is dire-diretso siya, dili siya yung ani. Okay? CRT video monitors operate in the low kilovoltage range and therefore emit some low energy X-rays along with the light image. So that means na ay low kilovoltage. So that means na ay kumbaga na ay patient dose. Okay? So viewers should sit back at an appropriate distance from the TV. Mao nang ginapaatras na to tong mga nagatanaw sa TV so that di lang siya because makaguba siya og mata, but also it can provide low energy X-rays which can provide significant amounts of patient dose kung dugay mo nagtanaw sa TV na close pa gyud ang range. Okay? With aging, the electron beam can suffer from blooming, increasing its diameter and thus striking more phosphorus than intended on the screen. Again, with aging, the electron beam can suffer from blooming, as in kanang blooming na guwapa, increasing its diameter and thus striking more phosphorus on the screen than intended. This causes resolution to deteriorate over time. So, pag old na kayo yung monitor or CRT na TV, it will cause blooming. And when this blooming occurs, its diameter na ginaproduce sa inyong electron stream will increase, affecting other phosphors na dili naman intended na ma-expose. Okay? So this will decrease resolution, which will deteriorate even more over time. Okay, the raster pattern in conventional TV tubes consists of 525 and a half lines. Sorry. The raster pattern in conventional TV tubes consists of 525 and a half lines. Digital fluoroscopy requires higher resolution and therefore more lines of smaller width, nipis, per frame. Special systems, what it means by lines kaning sa raster pattern ba? This one. So dapat the nipiser, the higher is the resolution. Okay, the more lines and the smaller the width, the higher the resolution and the more frame rate, which is much better kaysa sa low frame rate. Okay, special systems can be acquired with 825 line or 1024 line rasters. The raster pattern of the CRT monitor must be precisely synchronized with that of the TV camera tube, which picks up the signal from a fluoroscopic image intensifier. So sa fluoroscopy man good, di ba? Pag mag-opera tawag pasyente and we use fluoroscopy, it is much better because we see real-time images. Dynamic siya, mulihok-lihok siya. So makita nimo kung asa na mag-insert og needle, asa na dapit imong catheter, may ngana. Okay? So that is why we need high resolution na mga systems and high frame rate and smaller width na line so that accurate ba ang there is image accuracy kumbaga. Okay, kung asa na ba ang needle, nakatusok na ba ta sa area, pwede na ba ta mag-extract ng ana. So that each pixel is displayed at the exact location within the field of view that it was originally detected. Okay? So kung usa tong nadawat sa inyong TV camera tube, dapat ingato pud ang placement niya sa inyong CRT monitor so that walay walay interference. Okay? Dili sila mag-differ from each other and seamless gihapon ang pagproduce sa image. A 1024 line monitor requires a 1024 line camera tube. So, dapat same gid sila. Okay? The image display monitor remains the weakest link in fluoroscopic imaging. So, as you can see, in some of the fluoroscopic imaging systems, ang ginagamit gyapon nila is cathode ray tube, which is obsolete na siya. Okay? We have the LCD systems, we have the plasma display systems. Mo na lang gid na ang nahibilin na obsolete sa fluoroscopy systems. I don't know why dili sila mag-resort sa plasma panel or LCD TVs. Okay? Now we go with the laser film. So this is just a brief description of the laser film. A laser printer uses digital electronic signal from an imaging device. So mura siya kumbaga ka ng printer po yun sa computer, although ang ginagamit lang aning laser printer is a film. It is a high contrast single emulsion film with extremely fine grain, also known as IR film. So unlike itong ginagamit ito sa film screen system, which is double emulsion, kani siya single emulsion lang siya with fine grain. So medyo grano gid, as in kanang powdered gid siya na grain. Laser film is a silver halide film sensitized red light or laser light. Okay? So panchromatic siya na film, dili siya orthochromatic, which is sensitized by your green light. Okay? And also unlike your film screen, which is walay sensitivity sa, wala siya na sensitized to any other light because when it is introduced to light, of course, ma-expose na ang film, rendering it not usable for processing. This film can either be used in film digitizer or film printer. A film digitizer creates a digital image from a hard copy or a radiograph. Okay, so when we say film digitizer, pag naa kay film, if you just have to feed it in the film digitizer and it will provide you a soft copy of that hard copy film. And a film printer, of course, transforms the soft copy which is in the monitor into a hard copy or radiograph. Okay? So mo siyang difference sa film digitizer. From hard copy, may mo siyang soft copy. Si film printer, from soft copy, may mo siyang hard copy, such as a radiograph. So that would be all. I really hope that you understood all of the processes, although medyo lisod siya sabton, but with proper repetition, balik-balik o basa, you'll be able to understand it just like I did. Okay? If you have any questions, please do not be afraid to message me. And mao lang to. Of course, mag-quiz gyapon ta after Annie. Okay, after this topic. Thank you and goodbye.